right, hey guys, Miss Miranda here again. Today we're going to go over lesson 11.2, and lesson 11.2 focuses on classifying triangles. Now, when I did the previous video for lesson 11.1, we kind of went a little bit over some of the different types of triangles, but today we're going to go more in depth. All right, so basically what we're going to be doing is classifying triangles based on two categories. So we're going to look at each triangle's sides, and we're going to look at the angles of each triangle. All right, and we're going to come up with basically like a first and last name for the triangle. All right, but first let's go ahead and kind of go over what the different names are based on the measurements of the sides of the triangle. All right, so this first triangle we have here, if we look at only the sides, each side has a length of 3 inches. So we got 3 inches, 3 inches, 3 inches. All the sides in this triangle are congruent. Therefore, a triangle that has all sides equal would be called an equilateral triangle. All right, so all sides equal, 3 inches, 3 inches, 3 inches. That means all of these lengths here are the same. It's an equilateral. All right, our second triangle here, and again, we're still looking only at sides. We have 4 feet, 4 feet, 2 feet. So we have this side and this side that are congruent to each other. We have 2 sides that are equal, or 2 sides that are congruent. When a triangle has 2 congruent sides, it is called an isosceles triangle. And for this, I kind of like to think of the word ice cream, like an ice cream cone. If you look at an ice cream cone, this kind of looks like an upside down ice cream cone. But if you think of an ice cream cone, it kind of looks like an isosceles triangle, right? And then of course your ice cream on top. So if it looks like an ice cream cone, isosceles. All right, and last but not least, on this side here, and I'm going to move that up so you can see, we have 1 centimeter by 6 centimeters by 7 centimeters. So here we have no sides congruent at all. When that happens, it is called scaling. All right, so when we classify triangles based on only their sides, these are the 3 names that you're going to give it, one of those 3. So if all sides are equivalent, equilateral. If only 2 sides are congruent or equivalent, isosceles. If none of the sides are equivalent, it's referred to as scaling. All right, so that's triangles, classifying them based on sides. If we look at classifying them based on their angles, all right, this first triangle here, again, I'm not looking at sides this time. I'm only looking in here at the measurement of the angles. All right, each angle measures 60 degrees. I know that if it measures 60 degrees, those angles are all acute, because to be acute, it has to measure less than 90 degrees, and these are each 60. So because I have 3 acute angles, this is called an acute triangle. All right. The next one here, I have 2 45-degree angles, but then I have this special angle right here. It's a 90-degree angle. 90-degree angles, which form a perfect little box like that, are called right angles. When I have 1 right angle in a triangle, automatically that is called a right triangle. All right, it doesn't matter that these 2 are acute and I don't have all right angles, because if you think about it, you cannot make a triangle with all angles being right angles. It's impossible. You can't. If you don't believe me, try. All right, and the last one here, we have a 40-degree angle up here, we have a 30-degree angle here, and we have 110 degrees over here. This angle right here is greater than a 90-degree angle. When an angle is greater than 90 degrees and less than 180, of course, because if it's 180, it would be a straight angle. But this angle here would be referred to as obtuse. When you have 1 obtuse angle and 2 acute angles, this triangle is referred to as an obtuse triangle. All right, so when we classify based on angles, you're only looking at the measurement of each angle inside of the triangle. If all angles are acute, it's called an acute triangle. If 1 angle is a right angle, it's called a right triangle. If 1 angle is obtuse, it's called obtuse. All right, hopefully this makes sense. Let's look at some examples here. All right, so we're going to classify these triangles. We're going to give it a first and last name to each one. So this first triangle I have here, first I'm going to look at the sides. So I'm looking that one side measures 6 feet, 5 feet, and 7 feet. Are any of these sides congruent? No. Because they're not congruent, this triangle here is going to be scalene. All right. And then I'm going to go ahead and look at the angles. When I look at these angles inside of my triangle, I notice that this one is 42 degrees. That's less than 90. That means that this angle is acute. This one is 87 degrees. That's still less than 90. That's acute. And then this one is 51 degrees. That's less than 90. That's acute. So I have 3 acute angles. If I have 3 acute angles, that's right. This is acute. So guys, meet scalene acute. First and last name. Scalene acute. All right, so we named that one. Hopefully that was simple. All right, let's look at our next one here. We're looking only at the sides this time. These little notches here represent that those sides are all equivalent to each other. They're all congruent. So that means that I have 3 congruent sides. Therefore, based on my sides, this would be equilateral, right? And then if I'm looking at my angles, these little notches also tell me that these angles are all equivalent to each other. All right. Now, if I were to sit there and actually calculate the number of degrees inside of a rectangle, just like a circle would be 360 degrees, a triangle would be 180 degrees. So basically what this is telling me is that each angle here is 60 degrees. All right. Now, if I have 60-degree angles, that means that they're all less than 90. Therefore, this triangle would be acute. So guys, meet equilateral acute. First and last name. All right. Down here, we're going to look at sides first, just like we did before. So if I look at my sides, I notice 2 little notches. All right. Those 2 little notches tell me that there are 2 sides that are congruent. So when I have 2 sides that are congruent and one that's not, so 2 congruent sides, it looks like an ice cream cone, right? If I were to turn this over, so this would be isosceles. All right. And if I look at my angles inside, this tells me that these 2 angles are the same. All right. And this one is the only one that's going to be different. But when I look at these angles, I know that 30 degrees is less than 90. So this is going to be acute, right? This one here, this angle here, that doesn't look like a right angle or obtuse angle. That looks like an acute angle, right? And this one here, if I look at it, that also looks like an acute angle. So basically all these angles in this triangle are acute. Therefore, it's called acute. And I just noticed they're all acute based on the angles. All right. So let's look at the last one here. The last one, they didn't give you a picture. They gave you the measurements of each side of the triangle. So it's up to you to go ahead and figure out, based on the sides, what type of triangle this would be, and based on the angles, what type of triangle it would be. So when I look at my side measurements, I see 2 inches, 5 inches, and 3.5 inches. Do any of these numbers match each other? No, nothing there is congruent. So when I have all sides that are different, what type of triangle would that be? Yep, scalene. All right. And then when I look at the angles for this one, the angles are 30 degrees, 120 degrees, and 30 degrees. So I notice that I have 2 acute ones, right? 2 acute angles, but then I have this one right here. What type of angle is a 120-degree angle? Yep, that's obtuse. And when I have 1 obtuse angle and 2 acute, what type of triangle is that? You got it. You're so smart. It's obtuse. So for this one here, we don't need a picture. As long as they give us all 3 measurements for the sides and the angles, you can figure out what type of triangle that is. So meet scalene obtuse. Hopefully that was easy. Can't wait to see your work later today. Have fun. Toodaloo.